We're going to use the definition of the derivative to differentiate f of x equals to tangent x. Now to do this, we'll need to use two results. First one is the trig identity tangent alpha plus beta is equal to tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. And the second result, which was derived in an earlier video, is the limit as h goes to 0, tangent of h over h is equal to 1. Once we have these results, we'll be able to use the definition to find the derivative of tangent of x. So recall the definition of the derivative of a function. It's f prime of x equals the limit as h goes to 0, f of x plus h minus f of x divided by h. And let's apply that to the function at hand, which is f of x equals to tangent of x. Therefore, f prime of x equals the limit h goes to 0, tangent of x plus h minus tangent of x divided by h. To continue, we will have to use the trig identity outlined above. So right here we'll expand tangent of x plus h using the trig identity result 1 with alpha being x and beta being h. So our next step is to say this is equal to the limit as h goes to 0, tangent of x plus tangent of h divided by 1 minus tangent of x times tangent of h minus tangent of x all over h. From here, we'll use a little bit of algebra by finding common denominators and expanding. This is equal to the limit as h goes to 0, tangent of x plus tangent of h divided by 1 minus tangent x times tangent h. And right here I'll use common denominator. So I'll take tangent of x and multiply it by 1 minus tangent of x times tangent of h divided by 1 minus tangent of x times tangent of h. And of course all of this is divided by h. Now let's do a couple of more steps before we actually find the answer. This is limit as h goes to 0. We have tangent of x plus tangent of h, and then minus tangent x times 1 is minus tangent of x, minus tangent x times minus tangent x tangent h, that would be plus tangent squared of x times tangent of h, and all of this is divided by 1 minus tangent of x times tangent of h, and all that is divided by h, but that's equivalent to having h multiply 1 minus tangent x tangent h in the denominator. So now we see that we cancel tangent x and tangent x, and what we have left in the numerator is tangent h plus tangent squared x tangent h, which have tangent h in common. This is limit as h goes to 0. We'll factor out tangent of h, and then that's times 1 plus tangent squared of x. And in the denominator we have h times 1 minus tangent of x times tangent of h. And we can break this up into two limits. First, note that 1 plus tangent squared x is secant squared x, so we'll break this up into two limits. The first limit is limit h goes to 0, tangent of h divided by h. And we know that's our second result. This limit is 1. And the second limit is the limit h goes to 0, 1 plus tangent squared x. Now we can write it as secant squared x divided by 1 minus tangent of x times tangent of h. Now let's look at the second limit. The second limit only has an h in the denominator. As h goes to 0, tangent of 0 is 0. So tan x times 0 goes to 0. We have secant squared in the numerator, 1 in the denominator, which is just secant squared. So this is equal to 1 times secant squared x, which is secant squared of x. And that's the result we wanted to derive. We now know that if our function is tangent of x, using the definition of the derivative, we found that its derivative of prime is equal to secant squared